take a look and see if there's anything in particular. Honestly, I'm just opening this up to, I know we had the two different sheets. We had the graph review stuff. This is, the graphing review one was from Thursday, I want to say. This one I gave you guys on Thursday. It had all the images of pictures of them on the back. Let's start with that one since I have it open. And let's see if there's anything in particular that you want to look at. Yes, sir?
9.
Sure. So, on this graph one, I'll start with 8. Remember, as you're going through these things, there's certain scenarios that you always want to follow. You always want to follow kind of the same pattern with these things. First thing you want to do, always, is get your x-intercepts. Do that first. To get your x-intercepts, you always factor your numerator. Okay? So if I factor out my numerator, I get x, and then I have an x squared plus 2x minus 3, which means my terms will be x plus 3, x minus 1. So my x-intercepts will be at 0, -3, and 1. Okay. I do the same basic thing then to find my vertical asymptotes. So my vertical asymptotes are going to be at the zeros of my denominator. So I factor my denominator. Now, when I factor the denominator, what I'm going to do is take out the negative x first, and I get x squared plus x minus 6. The reason that I take out that -1 is so that way I don't have to worry about factoring a trinomial with a negative a value. That's not fun, okay? Because that doesn't change my 0 here. My 0 there is still going to be at 0, right? So I have vertical asymptotes at 0, and then when I factor this guy out, I'm going to get plus 3 minus 2. So my vertical asymptotes are going to be at x equals 0, -3, and 2. Okay? Now, this is where you were thinking, oh, wait, why are there's intercepts and all that? What happens here is if you look at your denominator, factored denominator and your factored numerator, see how the x's and the x plus 3 is what is simplified out? That's why there's a hole, okay? But what I'm asking you guys to do is not worry about telling me where the holes are. I want you to list everything. If you can list everything, I'm cool with that, okay? From there, we've got our vertical asymptote, we got our x-intercepts. What's our y-intercept going to have to be? Can I have a y-intercept on this one?
No.
I shouldn't, because if I put 0 in for x, I get 0 in my denominator. So my y-intercept doesn't technically exist. The only other thing that I can do here is find my horizontal asymptote. Our degrees are the same in the numerator and the denominator, so that means my horizontal asymptote is going to be at -1. Very good. So our last little bit is the horizontal asymptote at y equals -1. The leading term coefficients. So it's 1 over -1. Whenever the degrees are the same, that's how you get your horizontal asymptote. Okay. It goes back to that problem where we were doing in 9.2 where you had that linear over linear. It was just leading term coefficients. Okay. Yes, sir.
So if I find that I have x-intercepts or y-intercepts that are the same as one of the asymptotes, that would be
You still just write. You can still write it because you're just listening things through because you don't know what a hole is. It's just fine. I'm not really too worried about that. Okay. Yes, sir. Can you divide by 0? Yes, sir.
So you got -3, 2, and 0 for the vertical asymptote.
Yes, sir. Yep. Yeah. Are we okay on 8 then?
Oh, yeah.
No, because you don't have to calculate and do all that. You're listing things. I mean, honestly, the only thing you can do here is you can plot your asymptotes. You know, you've got asymptote at 0. What do we have? Asymptote at -3. You have asymptote at +2. Asymptote was at -1. Oops. Let's make that -1 a little bit bigger. And then you had technically here, here, and here. I mean, there's really nothing else you can do because I'm not going to give you, you don't need to I'm not going to give you a calculator trying to mess with all that.
Okay.
You just list, you can list things through, we're going to be good.
Okay.
For the weird ones. Alright. Remember, the only ones that I had you graph are the ones where you had that AHEK or that linear over linear. They actually plot the order pairs. Okay. You said number 9 also?
Yeah. I think it's the same thing.
I remember this one had.
This school looks weirdly graphed out from the graph on the map.
Yeah, and that's okay. But don't worry about it. Okay? Again, I'm not going to make you guys graph something like this, just like actually write it all out, because I'll have you list everything, but you don't have to worry about actually plotting the points, because you need to, I'd rather have you use a calculator to get your ordered pairs. But your x-intercept, oops, is at x equals -2. Your vertical asymptotes, well, take out the -4, we have x squared minus x minus 2, so that is -2 plus 1. So our vertical asymptotes are at 2 and -1. And then the last little bit there is to find the horizontal asymptote. And since the degree in the... I took out the -4. It has nothing to do with it now. Remember, there's no variable here. Okay, it's just a constant. Okay? Yeah. Yeah, and x. Yep, yep. Just like we did with the cubic. Because remember, if it was the third degree, how many zeros would you have? 3 of them. Here, there's just the second degree, which means there should only be 2 zeros. So that's that other little trick issue as we've learned through. Okay. And then the last little bit is just your horizontal asymptote, and I believe this one's at 0. Okay. So your horizontal asymptote is at 0. And the only other thing you can do here is your y-intercept. This one I can get a y-intercept. Where's my y-intercept? It's at 1/4. The reason that it's 1/4 is because you throw in 0 for x, you get 0 plus 2, 0, 0, 0 plus 0 plus 8, so 2/8, because you couldn't get away from buffet, is 1/4.
And you only get like a y-intercept as well. There's like no x.
Correct. Well, you could have a y-intercept at 0 if you have a, it just depends on the values. Okay. You're about to ask something else?
I was going to ask.
0 for x. In this case, it works because there's no, you're not divided by 0.
Well, how much?
What else on that graph sheet do you want to go through? I don't think that one was terrible, honestly. I don't think that was too bad.
Wait, y?
Yeah, 2/8. Because you can get away from the effect. Ms. Warren? The degree in the numerator is less than the degree in the denominator, so it means it's at 0. Remember the rules? You had the 3 rules. They were either it was greater, less than, or equal. So if it was greater, there wasn't one, but there could be a slant if it was one more. If it was equal, it was coefficients. But if it was less, it's at 0. Okay. What else we got? Yeah, there's one like that on the one you got on Friday, if I'm not mistaken. That's not one, but that's one we can do that one. Which number is that? 10? Let's say that's from Friday, right?
Well, this one's the graph.
Oh, okay, let's take a look at 10 real quick, or since we're right here. I think that one worked out pretty clean too.
Oh, these are the ones.
Yeah, this one wasn't too bad. Because this one actually, you can plot most of this one, but yet not have to worry about being too crazy with it. So here, again, we go through our list of things. Always start with your zeros of the numerator. That'll get you your x-intercepts. Here they're going to be at plus or minus 1. The vertical asymptote is what makes the denominator 0, and that'll be at -2. There's no horizontal asymptote. And again, the reason why there's no horizontal is because your degree of the numerator is greater than the degree of the denominator. But since they vary by just they differ by 1 degree, then we're going to have a slant asymptote. Okay. So since there's a slant asymptote, we have to do our long division. So we have 3x plus 6 into x squared plus 0x minus 1. Remember, always do placeholders. Okay. When I go from here, then what do you multiply? I'm just not going to worry about the. We all know it's going to be at some value of x, but what do you multiply 3 by to turn it into 1? I'm like 1/4. I'm going to go ahead and say no. So you get 1/3. Yeah, infinity. 1/3 x. Bring that through, we get x squared plus 2x. Subtract out, we have a negative 2x. What do you multiply 3 by to turn it into negative 2? Well, if you multiplied 3 by 1/3 to get it into 1, maybe multiply it by negative 2/3, so you get it to negative 2. And then after that, you know you're fine. Okay. So you'll have a slant asymptote at 1/3 x minus 2/3. Yes, sir?
What happens?
We don't worry about it. It doesn't have anything left to do with the problem. For that, we're just looking for the linear part of it, the mx plus b. Once we get to that, then we're good with the slant asymptote, because that generates your slant. Okay? It's the leftovers that got moldy in your fridge.
Oh, that's just one. What do you do again? Degrees higher, like
And then you won't have a slant. You only have a slant asymptote if the degree in the numerator is 1 off from the degree of the denominator. 1 higher. There is none, because the degree of the numerator is higher than the degree of the denominator. No, there is one. It's 0 if it's less than in the numerator than the denominator. Nope, there's no slant asymptote. Nothing. It doesn't exist. There you go. Right. I'm not going to, because I don't want you guys to use calculator. The sheet from Friday. Can you do that one? Anybody else around here Friday? Hey, look at that. What else do you want to look at on this one then? The one from Friday. Yes, sir.
What is the process of finding the y-intercept?
Throw x 0 for x. Remember how we did cover and solve when we did quick graphs? Same process still works. Sheet from Friday. Yes, ma'am. $20. So what I'm going to do is I'm going to write it down in terms of factoring right away. This is 20.
Thank you.
From this stuff? Not that I had. I think I over-reviewed as much of it as I have. So I want to multiply by something the least common denominator. Okay. The smallest amount that these guys are going to have in common just happens to be the x minus 4, x minus 2. So I have to multiply everything by x minus 4, x minus 2. Okay. When I do that, this one has the x minus 4, it needs the x minus 2. So we have x plus 5, x minus 2 equals 4x plus 4. I'm just going to redistribute that in there because I know I'm going to have to do it anyway. And then the last one, we have x plus 5, and then that one has the x minus 2, needs the x minus 4. So distribute out some stuff, FOIL, combine like terms. We're going to have x squared plus 5x minus 2x. We have plus 3x minus 10, 4x and 4. X squared plus 5x minus 4x means we have a plus x and a minus 20. Now it's easy, because you have variables on both sides of the equation, they just both happen to have the same coefficient with the x squared. It goes away. Okay. So now I have 3x minus 10 is 5x minus 16, I believe. Subtract the 3x, add the 16. 2x, and I get x is 3. Is that a restricted value for this problem? No. So we should be good. Can it be 3? The restricted values here, what gives you asymptotes? It gives you asymptotes here, we have 4 and 2. So if I get 4 or 2, I know it can't work. Those are your restricted values. They're an answer, but they're not an answer. Yes, ma'am? Extraneous, yeah. Restricted, extraneous means kind of means the same thing. For some reason, they just called it restricted. Which one? Yeah. I would. Oh, then you'd have to simplify and solve it like a trinomial factor. You still solve for x. Okay. 19, you said? Yeah. Same idea, 19. So I have 1 over x minus 1 is 1 over x minus 1 minus 1. Okay. That means my common denominator is going to be the x times the x minus 1. Are you okay with that? That. The common denominator is going to be the x times the x minus 1. Okay. So first fraction needs an x. Second fraction has it. Last one needs them both, but here's where you're going to screw up. It's minus 1 times the x squared minus x. I'm just going ahead and redistributing that back in because I know I have to do it anyway. What you're going to mess up is distributing that negative to the second term. You guys always, always, always screw that up. So x is 1 minus x squared plus x, bless you. Move everything to the left side, you're going to get x squared minus 1 is 0. So x is 1 or negative 1 plus or minus 1. Well, which one of those doesn't work? 1. In this case, 1 is an extraneous solution, but negative 1 will work. Okay. If you didn't do that one correctly, I guarantee you forgot to distribute the negative to the negative x, and that's usually where things go off. Okay. Okay. There's a couple ways you can do it. You could have written it as 1 over the x squared minus x squared minus x over x squared minus x. Combine the numerators together and cross multiply. It would have worked as well. More of a pain to do it that way, but. Okay. What do you mean by flip the sides? I moved it to the left. I subtracted 1, added x squared, subtracted x, and I got x squared minus 1. Okay. What else are we going to look at on this one from Friday? Which one? 14? Sure. I was just looking at that one. I figured most people were going to ask on that one. This answer on that one just sucks. There's no way around it.
Oh yeah.
This is 14, guys. So in this case here, you have to get common denominators twice before you do your same change flip. At least the denominators are somewhat easy to work with. It's just going to be 9 times the x minus 1. This one needs the x minus 1, so it's 16x minus 16 plus 36. I'm just skipping the step of writing it out because those are pretty easy to work with. So that new numerator would be 16x plus 20. I know at this point you're probably like, oh, I can take out 4 and see if that gets you anywhere. Remember, don't worry so much about that until you get all the way done to see if it's going to get you anywhere at the very end. Okay. Do the same thing with the second part. The denominator for that to be common is going to be 4 times the x minus 1. This one will have to FOIL out. So we have x squared minus x, and x minus 1. And then this one's going to be plus 12, 3 times 4. Okay. That numerator gives me, was it x squared minus 1? Yes. That numerator is going to give me x cubed minus x squared minus x, and then plus 12. All over 4 and the x minus 1. So there's your same, change it to a multiplication, then flip the bottom fraction. So you wind up with 16x plus 20 over the 9 times the quantity x plus 1, I'm sorry, x minus 1, excuse me, times the 4, x minus 1. And it's kind of boring because you can only do that for one thing, just the x minus 1s. Yeah. 60's a pass. 60. X squared times x is x cubed. X squared times negative 1 is negative x squared. Negative x times negative 1 is, oh, it should be, I'm sorry, this should have been a plus. Sorry, that should have been plus.
Yeah.
Minus, sorry. Did I miss one in there?
Yeah.
I did miss one, didn't I? X squared minus x, so, oh, sorry, x cubed. I did, I'm sorry, x minus x squared. So it's supposed to be minus 2x squared. Sorry about that. And then it was, thank you. Sorry, I missed that one. Thank you. Still can't factor it, so no big deal. And honestly, the only thing that's left to do is, remember I always say multiply out your numerators? You multiply out the numerator, you're just going to get, what's that, 32, that's 64x plus 80 all over 9 times the gross.
Yeah.
Can we use code like this?
Yes. Yes. Yes.
Yeah.
Okay. And then you're done with that one. It's just gross. There's nothing else you can really do with that one. Okay. What else we got? Besides me forgetting how to FOIL. I FOILed it out. I just accidentally forgot to put the extra term in there. 21. Guys. Let's see. That'd be minus 6 minus 4. So the common denominator here is just going to be the 6x. Okay. 21. So I multiply everything by 6x. If I do that, I'm going to get 18x is 3x plus, what was it, x squared minus 10x plus 24. Okay.
Why don't you it's also on.
Yeah, because what's 2 times 2 times 3 is what? That's why I had the x there. Okay. So combine all your terms, set one side equal to 0. This becomes negative 15, so I have 0. X squared minus 25x plus 24. And that's nice that it gives you something that's factorable. So you'll have x minus 24, x minus 1, so you have zeros at 24 and 1, and I don't think either of them are extraneous. That's a nice problem. I like that one, Kari.
So when should I include all the one side and one?
When you have an equal sign, set aside equal to 0. Easy way to think of it. Okay, what's that? Are you trying to think about when you're supposed to flip one to one side or versus the other? If you're the highest, you always want to have whatever your highest degree be positive. So move, as long as that's positive, then you move everything around from there. It was habit. I didn't need to. I don't know why. It just habit. But as soon as I write stuff down, I usually, I'm in such the mode of whenever I write something down in factor because I don't know. Okay. Didn't get me anywhere. It was good practice. Okay. What else, guys?
We just like a really simple problem. So like 5.
Ladies and gentlemen, 5.
Yeah,
Okay.
just like a picture.
So going back to 5, we've got 3x over 3 minus 6x plus 3 over x plus 1. So again, when you go through this one, there's a couple of things that you can do. You can immediately right away, yes, 5. You can immediately right away simplify out the 3's because you can, because they're already here. So this becomes just x over 1. So the common denominator is going to be x plus 1. Okay? So the first fraction needs the x plus 1. So you have x times the x plus 1 minus the quantity 6x plus 3. Again, what people will forget, subtraction of the terms. You have to make sure you distribute it to both parts. That's where most of you guys will make a mistake. So we get numerator is x squared plus x minus 6x minus 3. So it's x squared minus 5x minus 3 all over x plus 1. And then that would be done because you can't factor it from there. Okay? And that's usually where you guys will mess up. When you have that secondary term being subtracted, you will forget to distribute. Don't forget to distribute. Okay? What else we got?
Pick a hard one.
I don't know.
24. What do you think is the most challenging one? Because they all seem like decent, but you might as well go with something.
Just in case you
I'm sorry. What do you got? I'll get 24, so just ask for it. I'll get to it. No.
I'm gonna do photo math. You don't have
What is 24? What do you got? 24. 24 is negative 4x plus 16 over x cubed minus 6x squared plus 8x. So right off the bat, since you've got the denominator, each piece has a value of x. It means I know I'm not going to have a y-intercept, because if I throw in 0, it's going to be undefined. So x-intercept. 0 of my numerator is at x equals 4. My denominator, vertical asymptotes. I got a factor, take out the x, and I get x squared minus 6x plus 8. That gives me x minus 4 and x minus 2. So I have vertical asymptotes at 0, 4, and 2. Okay? The degree of the numerator was less than the degree of the denominator, which means your horizontal asymptote is located at 0. Very good. And then we know there's no slant because that, bless you, this is just a really gross looking problem. I'm not going to have you plot ordered pairs off of that, just like it's the degree of the numerator.
Could there be one where it's like,
Don't worry about it. Don't worry. Okay? And you go from there. All right? That's what 24 would look like.
So the degrees are on the bottom.
The horizontal asymptote's at 0.
Okay.
All right?
Yes.
right here?
Did you figure out that slant one?
Yeah.
Okay. You were there. You just. It's okay that you have fraction parts to it, and you did it right by when you multiply it to turn it into that. So you're doing fine. Okay. Let's see.
First one.
Yes. Because that's your AH and K, so your K value is 0.
Wait, hold on. Because there's no
Nope. There is no your x-intercept for these guys. Remember, when you're doing those, you have so guys. In one like this, you got your horizontal asymptote is the K value. Since there's no K value here, it means it's at 0. Okay. Your K value is 0 because you put plus 0 here. So your horizontal asymptote is at y equals 0. Oops. Your vertical asymptote is going to be at x equals 2. Okay. 0 denominator. And then from there, if you wanted to get your y-intercept, you can get the y-intercept. If you put 0 in for x, you get a y-intercept at -1/8, -1/8, excuse me. Okay. So in this case, I can graph this one because this is the style that you should be able to. You're at asymptote at 2, which means my ordered pairs I'm going to select 1, 0, 3, and 4. Okay. Horizontal asymptote was also at 0. Okay. What's 1 times 4? 4 minus 8. So you get -1/4. If it's 0, you get -1/8. So we already knew that. This is 1/4, very good, and 1/8. Now, you can overscale this if you want for your y values, just kind of make the graph look a little bit cleaner. So if I say 1 is here and -1 is here, that's perfectly fine. Because then I know if this way, this is half, so there's a quarter, and there's an 1/8. Oops. Sorry. There's a quarter, and there's an 1/8, so it's got to be doing this. And the same basic idea here. Okay. It doesn't have to be perfect when you graph those because you're telling me where the points are via the ordered pairs. Okay. Whenever you have vertical asymptotes, you pick the next 2 points to the left of the vertical asymptote, then the 2 points to the right of the vertical asymptote to get your ordered pairs. And they should mirror each other. Okay. They should bound around. All right. If you're using horizontal asymptote, then you'd have to set the fraction that 1/4x minus 8 equal to 1 and 2 instead of equal to -1 and -2 and solve for x. It's a lot more work. You can do it, but it's just not fun. Correct. That's why we always work with input to get output. Okay. What else we got? Sure. 22. Another one of those subtraction ones. Gee, I wonder what's going to happen here. So we have x minus 2 over x is 1 minus x minus 5 over x plus 4. 22. So I multiply everything by the x times the x plus 4 to get rid of my denominator. I'm sorry, I think I said x minus 4, I meant x plus 4. So that's going to be to get rid of my common denominator, to multiply it all out. So first fraction needs the x plus 4, so you get x minus 2 times the x plus 4. The one in the middle needs them both, so it's going to be x squared plus 4x. And then I have to subtract x minus 5 times just the x. Again, that third fraction is where most of you guys will make your mistake. Bless you, because you will forget to distribute the negative after you multiply it all out. All the way on the left, we have x squared plus 4x minus 2x, so it's 2x minus 8. Excuse me, x squared, 4x. This is x squared minus 5x, so it's minus x squared plus 5x. Okay? So far, so good? So the x squareds on the right-hand side go away, and I get 9x. Subtract the 9x over here, we get x squared minus 7x minus 8 is then 0. And then it drops us back into something that's factorable. Minus 8 plus 1. Possible zeros at 8 and negative 1. And I don't think either of them are extraneous. Nope, we should be okay. What do you mean? Sitting. You can do that. It's just more work. You can leave it how it sits. And it's fine. If I was going to move anything, I probably would have moved that the fraction all the way on the right. Just make it positive and just do it from there. But whatever. Yes, ma'am.
Would you distribute the negative side to the x or should you FOIL it and then do the distribution?
I would FOIL it and then do the distributive property. That way it's less stringent. Okay. What else we got? It's good fun. Hi. 13. All right. So 13, guys. 13, you have a common denominator from the top at 25x. So this one becomes 125 minus x squared. This one will also be a common denominator of 25x. This one needs the x, so it's 9x, and then it's minus, the other side just needs to be multiplied by 5. Okay. Same change flip. 125 minus x squared. 25x times 25x over 9x minus 20. And there's really nothing left to do. Does that work on that one? You okay?
Yeah.
Cool, yeah. Excuse me. What else, guys? Which one? What, Thursday? 5. So back over to 5 from the graph we want to get. First thing we do is take care of the numerator. So your x-intercepts was it x minus 4, x plus 2. So your intercepts are at 4, negative 2. Vertical asymptotes. Take out the negative 3, we have x squared plus 6x plus 8. So these are at so your vertical asymptotes at negative 4, negative 2. And then your horizontal asymptote in this case your horizontal would have been at negative 1/3. And then the only other thing you could have done is got the y-intercept in this case. The y-intercept in this case would have been at 1/3. Negative 8 over negative 24. That was on the Thursday one. That's how you would go with that one. No slant asymptote because the degrees are the same. We have the coefficients there. Again, it's not something I'd have you grab because you want to use a order. You'd have to use calculator to get all that. Yes, sir. Set x equal to 0. Remember, we've been doing the. Remember when I first showed you guys quick graphs? Yes. Remember cover and solve?
Yes.
Where's your y-intercept? Negative 2. Where's your x-intercept? 4. You're setting it equal to 0. That's all you're doing. Cover and solve. Throw it 0 in for x, that gives you your y-intercept. I know I have a y-intercept because the denominators, all parts, don't all have variables of the x, so I can get it. What else? You should know that. I'm always what's in your grade. Good clean fun. It's possible. Yeah, what'll happen, what happened, what I put on the test is, you know how we've always looked for x-intercepts, vertical asymptotes, horizontal asymptotes, slant asymptotes, y-intercepts? There's usually 5 things we're looking for. In this case here, we can find all of them except for a slant. So what would you put like an NA for not available, or just something, or write the word no. None, something like that. You don't have to, it does not exist. That kind of thing. Not 0, not anything like that. Only for the things that are possible is what you would write out. That way you remember to look for all 5 things. What else? What's that? 3 to the power of 4 would be 81.
81 to the power of 4.
Bigger number that ends in a 1.
Like, how do you know it's in a
81 times 81 is going to end in a 1. That number times that number is going to end in ends in a 1.
Log x equals 2.
So your h, your vertical asymptote will be at 5. So yeah. Excuse me. What's that?